Here in this video, we are going to do formation of ionic bond or ionic compound. It is given in this section 3.3, how do metals and non-metals react. Moreover, some of these board questions that have been asked based on this concept is, as you can see, I have written two of them. By the transfer of electrons, you have to illustrate the formation of sodium chloride, magnesium chloride. Also, you have to identify the ions present in them. And in the next part, I have taken another question. You have to explain the formation of the other way of asking this kind of question is to, you'll be asked to show the formation of an ionic compound, could be calcium oxide, sodium chloride, magnesium oxide by electron-dot structure. Same question, the other way of asking. In this question, as you can see, the atomic numbers of oxygen and the other one, calcium, is given. But it is always wise to learn the atomic numbers of few of the elements given in your table of textbook. I'll show you which table I'm talking. I'm talking about this table. The minimum number of atomic numbers that you should know is atomic numbers of these elements along with their, besides you have to know the atomic number, you should also know how to, this is not important, electronic configuration of these. You have been taught in class 9th about it, but now you have to recall these things in order to do formation of ionic compounds using electron-dot structure. Let's start with the first one, that is formation of sodium chloride. Let's say sodium chloride is NaCl, right? What we can do, first thing that you need to do is to write on the electronic configuration sodium whose atomic number is 11, configuration is 281. That means it has 11 proton, 11 electron and 11 protons. So what happens in order to attain the stable configuration or a configuration of noble gas, it will lose one electron. The lost electron should be shown on the right hand side. I'm showing it right hand side. Now, as you know, after losing electron, now its configuration will be 2, 8, where 2 electrons in the first cell, and that is first cell, and this 8 electrons in the second cell. After losing electrons, obviously it will be 1 electron short than the atom of the sodium, but the number of protons never changes. Any chemical reactions, number of protons does not change. Now, what you can see here that it has one more proton than the number of electrons. So it will carry 1 unit of positive charge. So we'll be writing 1 unit of positive charge over here. Now, similarly, we can show the formation of the other, that is chlorine. Chlorine, whose atomic number is 17. So configuration is 287. It has 17 electrons and 17 protons as well. Now it will gain 1 electron. The electrons gained is shown on the left hand side. Now you can check here that the number of electrons after gaining the new configuration become 288. As you know that 1 electron is added. Now it attained the inert gas configuration. After gaining 1 electrons, the number of electrons is going to increase. It was 17 earlier, now it is 18. Well, the number of protons, as I said, does not change in any chemical reaction, so will remain 17 only. What need to observe here that it has one extra electron than the number of protons, so it will carry 1 unit of negative charge. After this, showing the formation of how these ions are formed. Now, next we are going to do how these electrons transfer takes place. Now, first I need to write down sodium symbol. Moreover, you should remember that we only saw the number of electrons present in the outermost shell, right? Not of the whole. Like over here, we'll be showing for 7, and for chlorine will be 1, and chlorine for chlorine it is 7. Now I'll write chlorine. I'm using cross to indicate the number of electrons present in the outermost shell of chlorine. As you can see, it is 7 in total. Now there will be a transfer of electron takes place. So one of this electron which is present in the sodium will lose and the chlorine is gained. So in short, we can say there is a transfer of electron taking place from sodium to chlorine. Further, what you can see that after losing 1 electron, sodium has turned into 1 unit of positive charge. Make sure it is convention that you should put a bracket in the negative charge and indicating their electrons, not indicating the electron in the sodium as it has been transferred. So the final step will be, this is NaCl, and that is the formation of NaCl. Now, next we'll be doing the formation of magnesium chloride. For magnesium, what you should know, that is the atomic number of magnesium and atomic number of magnesium. I'm doing this formation of magnesium chloride. It is MgCl2. Now let's take how does it is formed using electron-dot structure. First of all, I'm writing magnesium. Magnesium, whose atomic number is 12, so configuration will be 282. As you can see, it has 2 electrons in the outermost shell. So in order to attain that stable gas configurations, noble gas configuration, it will lose 2 electrons. As I said, the lost electrons should be shown in the right-hand side. And after losing 2 electrons, you can clearly see that it has now the new electronic configuration as K shell has 2 electrons and L shell has 8 electrons. Now further, I'm showing the composition of these. It has earlier 12 protons, that is, I'm talking about the magnesium atom, and the number of protons was 12. After losing 2 electrons, it will be now 10 electrons, and the protons number, as I said, always remains same. Now we can clearly see that it has 2 more proton than the number of electrons. So it will carry this 2 unit of positive charge, that is magnesium ion. I've not disturbed the chlorine, as we are going to do the same thing. Now check here in the next part. I'm showing you the formation magnesium. As I said, we just need to show the outermost electron. There are 2 electrons in the outermost shell of magnesium, and the chlorine carrying is 77 electrons in the outermost shell. Now there is a problem here, that magnesium will, if it will lose 2 electrons, and chlorine, if it gains, will gain only 1 electron. So there does not come to an agreement, because after losing 1 electrons, magnesium still remain unstable. So what can happen, that another atom of chlorine can come, and let's see, I'm showing you the another atom of chlorine. Let me use a different color for you to identify between these 2 chlorine. Let's say I'm talking about another chlorine atom, and you can see here that it also will have the same number of electrons in the outermost shell. Now check here the transfer of electron, as it will take place 1 to this and 1 to this. Now, so the number of electrons after transfer is going to be 8. Now let's say how does this is formed. I'm going to show it finally. It's magnesium. As I said, we just need to write 2 plus here, but in chlorine, we must place them in a bracket, showing the convention involved. Chlorine, make sure you are representing just one symbol of chlorine, as although it is 2 in number, but make sure you write 2 in the subscript, right? Not over the power or somewhere else, or you cannot insert a 2 in between. So it must be written like this. Now let's now the final formation is what? That is Mg. It has 1 ion of magnesium, and chlorine being 2. So that's the reason why we write MgCl2. There is one more, that is calcium oxide. As you can see, I've taken calcium oxide. If you remember the calcium oxide, then we have to write down the atomic number of calcium as well as oxygen. Let's see how I'm forming it. So calcium, whose atomic number is 20, so its configuration is 2882. Right, I'm doing the formation of this. Now, as you can see, that calcium will also lose 2 electron, and after losing 2 electron, right, it will become Ca. Lost electron is shown on the right hand side. 2 electron lost here. New configuration will be 288, a stable configuration. Electrons was 20, protons was 20. After losing 2 electron, the number of electrons becomes 18, while the protons number remains same. So it carries 2 unit of positive charge, as it has 2 more proton than the number of electrons. Now next is oxygen. Oxygen, whose atomic number is 8, so configuration is 26. It's gaining 2 electron. All right, so oxygen will now, after gaining 2 electron, will have the new configuration as 28 with its gaining 2 electron. Let me show you the number of electrons was 8, protons was also 6 plus 2, 8. After gaining 2 electrons, sorry, its new number of electron is 10, but the number of protons is 8 only. We can clearly see it has 2 more electrons than the number of protons. It will carry 2 unit of negative charge. In the final part, I'm going to show the transfer of electrons, calcium. As I said, we just need to show the outermost electrons, not all the electrons. It has 2 electrons in the outermost cell. In this case, it is 6. Now I'll write oxygen here. Oxygen, I'm showing using a cross to indicate the number of electrons. As you can see, it has 6 crosses, one transfer from here, another transfer of electrons from here. So the 2 electrons get transferred from calcium. And the final formation will be, this is calcium, which showing is 2 electrons in the outermost cell. Oxygen, it's important to remember that we should place them in a box bracket, and then writing this as its charge over its superscript, writing or showing the number of electrons present in the outermost cell. It's not necessary to use color over here. I'm using it although. Now, as you can see, calcium losing 2 electrons and oxygen gaining 2 electrons, so they will have 1 ion each. So calcium oxide is this. Now, I have done the formation of calcium oxide, sodium chloride. Like in case of NaCl, if they give you KCl, it's all same. Is everything is same that in case of K, it is 288.1, and in case of sodium, it is 288. Everything will be remain same the way it has been formed. Likewise, I have shown you the formation of magnesium chloride here. Also, no, calcium chloride. If they, instead of calcium chloride, if they ask you for magnesium chloride, if they ask you for magnesium oxide, magnesium oxide. So all you just need to show is the same as calcium. There's just the electronic configuration of magnesium will be 282. The same way here also magnesium will lose 2 electrons as the calcium is doing. Further, if it is a calcium chloride, like in this case, they give you calcium chloride. If they give you for calcium chloride, say ClCl2 is going to be same. Here also calcium will lose 2 electrons, as I've shown for the formation of magnesium chloride, right? The way magnesium chloride is formed, same as calcium chloride. Because in case of magnesium chloride, the configuration is 282. In case of calcium, it is 2882. So the number of electron gained, lost will all be same. Just the symbol will change and the electronic configuration will change.